Social media and consumer product portals have successfully leveraged data analytics to match users with products, friends, or information, having a significant impact on lifestyle, economy, and politics. What if these technologies could be leveraged for policy deployment in our countryside, to identify optimal investment patterns and ecological approaches? We present LandMatch, an AI-based method that allows policymakers and agribusiness find partnerships and drive investment, helping deliver structural change both to the economic and ecological systems in UK countryside. LandMatch borrows techniques from social media and database retrieval. It stores data of farmers, ecological systems and local businesses coming from texts, documents, images and other sources. What sets LandMatch apart from other techniques is that it also remembers spatial data such as ecological corridors, hydraulic connectivity, and transportation. LandMatch stores data on a graph structure that complements AI-powered mechanisms, adding spatial intelligence. Let us see some examples of how we could be using LandMatch, starting from document processing for item identification. We are working on a prototype for the farms in Chichester. We used data for 100 farms sourced from Google and then generated 400 synthetic data points. We pick 3 farms to explain how the tool works. Each data point has a name, location, distance to a river to the sea, as well as a text description of features and production. This information is itemized for database comparison. We look at common points between farms, from its production, landscape components and geographic proximity. We can see which farms have more things in common, and which ones are better connected overall. These relations can be brought back to the real location of the nodes. We obtain a rich representation of the geography, where we can detect coherent areas, which are close in proximity and production, but also what nodes seem to be better placed to play a key role due to their potentially stronger ties. Our prototype allows us to search using traditional filters, as well as business ideas as queries. In this case, we search in Bosham, farms rearing cattle with artisanal food production, potentially linked to educational activities. We obtain the farms in the area ordered by relevance to the business ideas, as well as an overall commentary on the potential of the farms. We can now query the same area of Bosham, in this case sending the entire neighborhood plan and asking the model to digest it, obtain its main aspects related to livestock, and look for farms better positioned to act as exemplary case studies. In this case, we obtain different business priorities, as well as a summary of the potential in the farms for policy delivery. We now plan to increase system robustness, expand it to a national scale, and bring in local policymakers to make initial tests with the tool. The possibilities for policy making and delivering change are large, with multiple other applications both for farmers and policy makers.